The Asteroid 2025 FA22, a close encounter, media sensationalism, scientific scrutiny, and questioning institutional trust. In the immense theater of the solar system, asteroids serve as both ancient relics of planetary formation and stark reminders of existential vulnerabilities. On September 18, 2025, the date this essay is penned at 2:07 p.m. 05, an asteroid officially designated as 2025 FA22 is executing a close flyby of Earth, passing at a safe distance of approximately 842,000 kilometers, 523,000 miles, equivalent to about 2.2 lunar distances. This event, while offering astronomers a prime opportunity for observation, has been enveloped in a cloud of media exaggeration, with outlets dubbing it a skyscraper-sized monster, previously predicted to slam into Earth in 60 years, now hurtling by at the last minute. The query highlights a purported approach at 24,000 kilometers, a figure that seems to confuse the asteroid's velocity of around 24,000 miles per hour, approximately 10.79 kilometers per second, with its actual distance, and invokes a narrative of a long-term forecast suddenly morphing into an urgent announcement. This essay expands the discussion by incorporating additional examples of similar asteroid events, delving deeper into technical details such as orbital mechanics and potential impact scenarios, and critically examining the trustworthiness of communication channels. Specifically, it questions the reliability of media outlets, NASA, governments, and observatories, drawing on historical precedents where information has been sensationalized, delayed, or potentially manipulated. By weaving in these elements, we not only dissect 2025 FA22 but also illuminate broader systemic issues in how cosmic threats are conveyed to the public, fostering a healthy skepticism amid scientific progress. Discovery and initial observations, the mechanics of detection. Asteroid 2025 FA22 was first spotted on March 22, 2025, by the Panoramic Survey Telescope and Rapid Response System, PAN-STARRS-2, at Haleakala Observatory in Hawaii, a cornerstone of NASA's Near-Earth Object (NEO) observations program. PAN-STARRS employs wide-field cameras to scan the skies nightly, detecting moving objects against the stellar backdrop through automated algorithms that compare sequential images. This discovery exemplifies the program's efficiency, having catalogued over 30,000 NEOs since its inception in 2010. The asteroid's provisional designation reflects its discovery year in sequence, later confirmed by follow-up observations from telescopes worldwide, including the Catalina Sky Survey in Arizona and the European Space Agency's Optical Ground Station in Tenerife. Estimated at 130 to 290 meters, 427 to 951 feet, in diameter, roughly the height of the Empire State Building or twice that of London's Big Ben, this potentially hazardous asteroid, PHA, could unleash devastating energy upon impact, equivalent to 1050 gigatons of TNT, dwarfing the 1908 Tunguska event, 15 megatons, that flattened 2,000 square kilometers of Siberian forest. For context, a 200-meter object like this could create a crater 4-5 kilometers wide and trigger tsunamis or climate-altering dust clouds if oceanic. Initial spectral analysis suggests a stony composition, typical of S-type asteroids, but radar imaging during the flyby via NASA's Goldstone Deep Space Communications Complex aims to refine this, mapping its shape, possibly irregular, like a potato, and spin rate, potentially tumbling every few hours. However, the trustworthiness of these initial reports warrants scrutiny. Observatories like PAN-STARRS, funded by governments and NASA, operate under protocols that prioritize data sharing via the Minor Planet Center at Harvard-Smithsonian. Yet, historical delays in reporting, such as the 2013 Chelyabinsk meteor, which injured 1,500 people without prior warning due to its small size, 17 meters, and sunward approach, raise questions about detection gaps. Could funding constraints or bureaucratic inertia lead to selective transparency? Moreover, conspiracy theorists point to alleged cover-ups, like unsubstantiated claims that NASA withheld data on the 1998 XF-11 asteroid's initial high-impact probability in 1997, only to revise it downward after public outcry. While these are often debunked, they underscore a public distrust fueled by opaque processes. Orbital characteristics and close approach details, a deeper dive. As an Apollo-class NEO, 2025 FA22 follows an eccentric orbit with a semi-major axis of about 1.5 astronomical units, perihelion near 0.9 astronomical units, inside Earth's orbit, and aphelion extending to 2.1 astronomical units, crossing Earth's path biannually. Its inclination of roughly 10 degrees to the ecliptic plane and orbital period of 1.8 years facilitate periodic close encounters. The minimum orbit intersection distance, MOID, with Earth is approximately 0.001 astronomical units, 150,000 kilometers, qualifying it as a PHA under NASA's criteria, MOID and Lieutenant, 0.05 astronomical units and diameter and GT, 140 meters. During the September 18, 2025, flyby at 7:41 Coordinated Universal Time, the asteroid approaches at 0.00563 astronomical units, 841,988 kilometers from Earth's center, moving at 10.79 kilometers per second relative to Earth, fast enough to cross the Atlantic in under 10 minutes. At peak brightness, magnitude 13, it's observable with 8-inch telescopes in dark sites, appearing as a fast-moving point in constellations like Aquarius. Live streams from the Virtual Telescope project in Italy and Lowell Observatory enhance accessibility. Comparatively, this is farther than the 2011 MID's 12,000 km pass or 2012 DA14's 27,700 km flyby in 2013, which coincided eerily with Chelyabinsk. The 24,000 km confusion likely arises from misreading velocity stats, a common media error that amplifies perceived danger. But questioning trustworthiness here, NASA's Jet Propulsion Laboratory provides precise ephemerides via the Small Body Database, yet governments might classify sensitive data during geopolitical tensions. Imagine a flyby amid US-China rivalries, where orbital intel could have military implications. Observatories' reliance on public funding also invites bias. For instance, the Arecibo Observatory's 2020 collapse due to neglect highlighted underinvestment, potentially delaying detections. The 60-year prediction and last-moment announcement, unpacking the hype. Initial calculations post-discovery flagged a 0.01% impact chance for September 23, 2089, about 64 years away, placing it temporarily on ESA's risk list and NASA's Sentry system. Refinements by May 2025, incorporating more astrometric data, eliminated this risk, projecting safe passes in 2089, 3.7 million kilometers, and 2,173, 320,000 kilometers. Media latched onto the 60-year doomsday angle, with headlines like skyscraper-sized asteroid previously predicted to hit us in 60 years, from Live Science, evoking apocalypse despite the probability being lower than a lightning strike. This last-moment narrative stems from intensified alerts in September, tied to the International Asteroid Warning Network's (IAWN) exercise treating 2025 FA22 as a deflection drill. Examples abound. The 2004 Apophis discovery sparked global panic with a 2.7% 2029 impact chance, later reduced to zero, but not before tabloids proclaimed end of the world. Similarly, 1950 does 1 in 300 odds for 2,880 were hyped, ignoring refinements. Media's clickbait model, Fox News, massive asteroid bigger than skyscraper heading Earth at 24,000 miles per hour, prioritizes fear over facts, eroding public trust. Critiquing NASA and governments. While NASA's updates are data-driven, transparency issues persist. The 2024 YR4 asteroid's probability fluctuated from 1% to 0.004% for 2032, prompting questions about initial overstatements or computational errors. Governments, via agencies like Roscosmos or CNSA, sometimes delay international data sharing, as in the 2019 FT3 hype where Russian media accused NASA of underplaying risks. Observatories, too, face scrutiny. Private ones like B612 Foundation criticize NASA for underestimating threats to secure funding. Is this genuine concern or institutional self-preservation? Broader implications for planetary defense, strengths, gaps, and skepticism. 2025 FA22 highlights planetary defense advancements. NASA's DART 2022 successfully altered Dimorpho's orbit, proving kinetic impactors. ESA's HERA 2026 will assess aftermath. The NEO Surveyor telescope, launching 2028, aims to detect 90% of 140 meters plus NEOs. Yaun simulation fosters collaboration among 30-plus nations. Yet, only 40% of such NEOs are tracked, leaving blind spots for surprises like Chelyabinsk. Media hype, as in the 2018 Lars bus-sized fireball over Botswana, misreported as imminent doom, distracts from real preparations. Questioning trustworthiness, NASA's dual-use tech, e.g., radar for military tracking, raises concerns about classified data. Whistleblowers like Edgar Mitchell alleged UFO, asteroid cover-ups, though unproven. Government's pandemic responses analogize potential mishandling, delayed warnings for political reasons. Observatories' peer review delays could withhold critical info, as speculated in the 2003 NT7 case. Positively, events like this spur STEM interest and international treaties, like the UN's Committee on the Peaceful Uses of Outer Space. Conclusion. Asteroid 2025 FA22's safe passage on September 18, 2025, at 842,000 kilometers exemplifies cosmic serendipity, far from the dramatized 24,000 kilometers peril. Expanded details reveal its orbital intricacies and hypothetical devastation, while examples like Apophis and Chelyabinsk illustrate recurring patterns. Yet, questioning media's sensationalism, NASA's fluctuating predictions, government's potential secrecy, and observatories' biases is essential for informed discourse. Trust must be earned through transparency, not assumed. As we gaze at this celestial visitor, let it propel not paranoia, but vigilant advocacy for robust, accountable planetary defense in our shared cosmic voyage.